I'm going to review another multimeter today. This one's a little bit different. Stick around to find out why. This has been sent to me at no cost by Banggood, so thanks so much Banggood for sending this to me. Usual disclaimer thing. It's a legal requirement. So, what do you have? You've got a little manual here. This is a Mustool MT8206. It's a waveform displayed multimeter as well, so it actually displays a waveform on AC. I haven't actually looked at the manual myself yet. I haven't actually played with this much. I've put some batteries in it and turned it on once and I had a quick look and haven't really used it yet. So it's a fully English manual by the looks of it. Every page is English. That's good. Technical specs, last page. Should have just gone straight there, shouldn't I? Let's have a close look at this. There you go, here's the specs for it, so read that in your own time. I might come back to this later on, actually refer to bits. So I think some of the main specifications to look at on this is battery life, because it's a 30-hour battery life, because it's got an OLED display, not an LCD. It's OLED, so it's a bit different. 128 by 64 dot matrix display. Main specs for DC voltage on a 400 milliwatt range, it's 0.75% of reading plus 10 digits. 10 digits! And then the other ranges are plus 1.5 or plus or minus 1.5% plus 10 digits divided by 1000 volts. Okay. AC voltage ranges are worse. It's 2% per reading plus 10 digits as expected and 400 millivolts. And plus or minus 1% or 5% plus 10 digits depending on the frequency. 50 Hz to 400 Hz and 400 Hz to 20 kHz. So it's like 20 kHz is the max. So we'll have to test it out. On the 750 volt range, it's 1.5% up to 1 kHz. Again, we want to test it out. DC amps 1.2%, AC amps 1.5%. All these all plus 10 digits. So that's quite a big error. 10 digits makes the last digit pretty much meaningless, doesn't it? Resistance. Oh, here we go. Let's get slightly better now. 1% or 3% with 5 digits, depending on the range. And capacitance 3%, 10 digits. Or this range here, it's 5% plus 15 digits. Frequency is 1% with 5 digits, up to 5 megahertz apparently. That's the manual. What does it look like? Well, get a little bag with it. Got standard probes. I will test those. Tilting barrel. Yeah, on this surface it is a little bit slippery to surface. If you're on a hard surface like me, then pushing these buttons it's going to move around because there's no rubber boots or anything. If they had rubber feet on here, then it'd be alright. So it takes 3 AAs and you have to put them in a certain sequence. You have to put the outer ones in first and the middle one in because they're underneath the sides of the cover. Not a big deal, just a little thing to watch out for, but 30 hours life, don't forget. Let's check the spacings on these. Here's one of my leads, just check up the spacing. Oh, yep, that goes in though. It's tight. It's really tight. Wow. Let's see these plastic sleeves. It's got quite a deep plastic sleeve before it gets down to the metal contacts. It goes down quite a long way before it even touches, so yeah, that's quite tight because of these plastic sleeves. So look at the functions. So we've got millivolts DC, volts AC, hertz and percent. So that's obviously duty cycle. We've got a multifunction here which is sounder, capacitance, resistance and diode check. You've got millifarad, obviously capacitance range as well. There's 2 capacitance ranges, like low capacitance, high capacitance, milliamps AC and DC, and amps AC and DC. They've also got the display button, relative button, select button, and hold, which have also got some second functions by holding them down. Yeah, so let's have a look at this. Actually, turn it on, shall we? Let's go. Got off at both ends. There you go. So you can see it's graphical OLED display. And depending on what mode you're in, you can change displays. And this is the graphical one. You have to hold it down for a second or two and it will change the graphical view. So if you're trying to monitor something, you can do that. I don't know if there's any adjustments on this once you're in there. Oh, you can. It's a bit slow to update. It's a bit slow. So 500 milliseconds. Down to 10 milliseconds. Okay. It doesn't feel that nice. I mean, it is indented really nice. The indents are really nice. But the actual movement, it feels a bit sort of, I don't know, crunchy. It feels like it's got a lot of drag on it. It doesn't like pop. It just, I don't know, maybe it'll free up the time or something, but No, it just doesn't feel that nice to me anyway compared to other meters. I mean, it's got a nice indent. The indent's nice and positive, but I don't like the actual feel of the drag across it. It's like it's plastic contact and it's dragging because it's not got a nylon bush in there or something. Anyway, multimeter leads. Look at these. Standard PVC leads, as you tend to get with a lot of these things. Cat 3 rated 1000 volts apparently. Sharp tips are not super sharp, they're alright. Okay, I'm going to do a test with these actually. It's, plug these in and we'll do a continuity test. Assuming it's in those two ports, it's not obviously clear. Let's go to there. That's in resistance mode. Let's just check resistance light, shall we? So 0. That's alright. But it is, as you can see, it's quite slow. Alright, so that's diode test mode. No beep on diode test. And continuity tester. Right, let's see how this goes. Oh, that's fast actually. Okay, let's do this properly. Right, so I've got Ian Johnston's DMM continuity tester which he sent me. It's a project he's designed and is available. I think it's open source. He has made the firmware and everything available for it and the PCB files and that sort of stuff. So if you want to, you can actually build one of these things yourself. So go and check out Ian Johnston's website, which is ianjohnston.com. Anyway, plug this in. There we go. So it needs a certain space ratio. I've got it set to minimum time right now. I've got it set to 250 milliseconds, which is pretty much the time we're going to use for most of these meters. And I'm just going to bring this up and we'll see where it starts to beep. There we go, starting to detect it there, 0.1 milliseconds. So 0.3 milliseconds. Alright, if I increase the space ratio, that's very fast. That's actually a really good response. Now, the only thing is that the display response is quite slow. Alright, so the continuity is good. Display updating is a bit slow for my liking. We'll see how it goes though, but so far it's looking like it's a bit slow. So I've just got Ian's PDVS2 Mini here as well. This is an awesome piece of gear. This is a 0 to 10 volt reference. It's an awesome thing to have. He hand builds these himself at his lab. These are really popular. If you can get one of these, I suggest you do if you're doing any kind of reference work. Good tool to have. Now I've only just turned it on, so it's going to be warming up. It's not going to be stable yet, but the resolution should be good enough for this meter. Let's do 1 millivolt. 0.9. Now don't forget this is still warming up, so it might have a bit of drift in there, so that's fine. Let's go 100 millivolts. I think it's a 4000 count, wasn't it? So 100 there, yep. So 400, very slightly out there. Yeah, that's the maximum as well, 400. 401, 402, 403, 404. Come on, it has to be 404, doesn't it? Maybe it's 409 is the top. Yeah. That's how much it'll overrange by. Okay, so that's that one. Oh, we should do the graphical display, shouldn't we? Here we go. So let's increase the time. There you go. So you can push it fast, it just takes a while for the display to update. Okay, so it's not like the whole width of the display, it's actually per dot. Based on how quickly it's moving across. Okay. So we'll do 50. If I change this up and down, should be able to see the actual waveform there as it happens. There you go. Resolution there is about 10 millivolts. Okay, well, that could be handy if you're trying to see if a power supply is being a little bit noisy or something, maybe. There you go, so you can see that's the resolution's coming up there like so. So it's not beautiful resolution on there, but it will give you some kind of indication. Right, so it's DC volts now. Let's check this one out, see what this one appears to be like. So 0.1 volts, it's not bad, one count out. Because despite the specs saying 10 counts, 10 millivolts is looking bang on, actually. 1 millivolt. Yep, we can see that. So the whole 10 counts error thing, well, in the specs, which are really loose, it's actually doing way better than the spec. That's a good thing. indicate 1 volt. Yep, so I think it's a 4 volt range. That's looking absolutely fine, bang on. It's a few counts out there. Look at that, 4 counts out. So it looks like this calibration is not perfect. It does drop off at the higher end of the ranges. So I think this is a 4 volt range. Yeah, it is. There we go. So I'll just pop them in the next range. There's 4 volt. This is very bottom of the next range up. And we got up to 10 volts, which is as high as this thing can go. And that's looking perfect. So we'll see how this goes in the calibrator as well. So make sure you do hang around for that. Also, don't forget to click like if you like the video, and subscribe, and click the bell icon if you're new here. So that's looking really good right there at 10 volts. That's good. But we'll check this on the calibrator. I'll put it through its paces. Check everything on the calibrator: AC, DC, current, duty cycle, that sort of stuff. We'll check all that on the calibrator. Oh, we'll also be doing resistance on the calibrator as well. So here are my standard capacitors: 200 picofarad, 20 nanofarad, 1 nanofarad. Oh, should be running the other way. And a 1 microfarad. I actually would like to find like a 10 microfarad standard cap, or maybe 100 microfarad standard cap. Haven't yet found them yet. It would be nice to find some. So if you know where I can get one, let me know. Alright, so let's start with a 200 picofarad. Let's go to capacitance mode. And we'll also select capacitance. There we go, capacitance, auto range. Just plug that straight in. So it's measuring 0.36 nanofarads. So that's about 75% out from what this thing actually is, which is 200.2 nanofarad. So that's no good. But it's right at the bottom of the range, and that is that accuracy spec there showing up, which we did know was not great, but on DC volts that's alright. So let's check it on these. So this is 1 nanofarad, 0.33 up, so it's like 30% out. Next one. This is a 20 nanofarad. That's actually slightly down. Okay. And the next one, which is 1 microfarad, is only a couple of counts out. That's actually looking pretty good, that 1 microfarad. That's actually looking pretty good. So it looks like the higher capacitances are going to be better than the lower capacitances, which is fairly common. But you would still expect a 1 nanofarad to show up, but as soon as it's within its range, you expect that to be more accurate than it is. So I'm actually really not liking how tight these probe connections are. I'm really worried about ripping the bloody things out of this connector here. You know, it's really tight. I'm not liking that. Yeah. Let's go and check this thing out in the calibrator. So, to the calibrator. Right, so at the calibrator, let's do millivolts first. We've got millivolts DC, volts DC, then we'll go through the AC stuff, and duty cycle and frequency, we'll do those on it as well. And then, well, we're just going to do 1 megahertz, but it should be good enough for this. And then we'll do resistance and current and what have you too. So, let's get started. Turn it on. So output is currently set at 0 microvolts. Do full range on that, 100 microvolts. It's just showing up, look at that, 0.1, 1 millivolt, that's okay. 10 millivolts, 1 count out. 100 millivolts, let's go to volts. So on the volts range, 100 millivolts, 1 count out. 1 volt, 1 volt, perfect. 10 volts, perfect. 100 volts, perfect. And it gives you, well, it's 1 count out, and it gives you a warning here about high voltage, which is quite nice. It beeped just to give you, hey, look, something's a bit high, this is a bit dangerous. That's good. So I wonder what the threshold is for that. So it looks like anything above 30 volts it considers a dangerous voltage. It's probably a bit low for my liking, but anyway, it's nice that it's got that feature. Let's do that again. So back to 100 volts. Right, so let's work up to the voltage now to see where it will actually give us trouble. So 200 volts, that's okay, out by 1 or 2 counts. 300 the same. 400's out by a few counts. 500's change ranges, so it's also a 400 volt range. Then it's a 1000 volt range. So 500 volts is bang on. 600 bang, 1 count out. 700 1 count out. 800 1 count out. 900 2 counts out. 1000 2 counts out, and gives you an overload warning. Okay. So now let's do AC volts. So I'm set at 1 millivolt. Well, will be. Getting 0 in there, which is good. Can't quite get 1 millivolt. Let's do 10 millivolts. That's showing up as 7. So 100 millivolts is 0.095. 1 volt, 0.99. Okay, it's getting better. Nothing gets that 1 kilohertz. It should be okay there though. 10 volts, 9.96. It's well within its spec. So 100 volts, it's a few counts out, but also beeps and gives the warning about high voltage. So 200 volts, 1 count out. 300 is 4 counts out. 400 is 8 counts out. 500, 3 counts down. 600, 2 counts down. 700, almost bang on. I'm guessing it's calibrated at the very top end of that one. 800 it won't like. Yeah, although it reads it. That's above its spec, which is 750. Let's change frequencies. Right, let's do a different frequency now. Let's do 100 Hertz. And let's see how this goes. So it's currently 100 Hertz, 1 millivolt. It can't see it. 10 millivolts. 100 millivolts. 1 volt. 4 down. 10 volts is 3 down. 100 volts is 2 down. 200 volts is 1 up. 300 is 3 up. 500 is 3 down. 700 is 2 down. So let's check its accuracy with frequency. So at 1 volt, which is what I normally use for doing this test. So 50 Hertz, still reading at 20 Hertz. 10 Hertz is getting erratic. So 100 kilohertz it can't read, well not properly. 20 kilohertz it can read, but it's definitely off a bit. It's off by quite a bit there, isn't it? 2 kilohertz is like 10 counts out, which is the spec, isn't it? Plus a couple of percent, whatever it is. So 2 kilohertz at 1 volt. And it reckons the spec is 1 kilohertz there. So it can't do. So I thought let's come back and really look at this lower voltage ones with the frequency. So I've got a set of 5 millivolts, which I can actually see a reading on here now. So I'm going to check the very bottom end here and see how it goes. So we're getting 3 millivolts on there. So it is sensing down the bottom end. So it can't do any more than 1 kilohertz on the 400 millivolt range. So this is right at the top end what it's supposed to be able to do. Let's go down 100 Hertz. Does that change it much? It's exactly the same. That's what I wanted to check. So I'm going to check the frequencies again on the 10 volt range. It should be able to read that. It should be able to go up to 20 kilohertz. And it's doing it okay. This has got to 30 kilohertz. And it's dropping off, but it's still reading it. And 20 kilohertz is not actually right. So that's quite far out of spec, I think, there. Yeah, what's the spec say? Yeah, not great. But readings, you know, a long way off. I wouldn't really like that myself. A bit higher up, like 10 kilohertz, I'd say is probably pushing it. So let's check duty cycle and hertz, or frequency. So we're doing 10 kilohertz and it is measuring 9.99. 100 hertz, so I can read that just fine. It's supposed to be go down to 5 hertz. 10 hertz is fine. Look at that. It's jumping around a little bit, but it can see it. Yeah, that's alright. That's fine. So 100 kilohertz it can read as well. That's good. 1 megahertz also fine. Just 1 count out. So that's actually doing okay. So let's look for duty cycle. And as you can see, it's jumping around a little bit. So let's try lower frequency. Yeah, that's better. It's handling it better. But it's not quite right. It's a couple of counts out. Yeah, about 2 counts out, basically right across. And the spec for that is 1% plus 5 digits. And amplitude not less than 2 volts peak to peak. So let's do resistance now. So I've got this set to 0 ohms, and yeah, we're getting 0 ohms. That's alright. So at 10 ohms, we've got 10.42 here, getting 10.4, 10.5, flicking around. So that actually looks alright. So 100 ohms, 100.4, getting 100.5, it's 1 count out. So 1k, 1 count out. 10k is 1 count out. 100k is 2 counts out. 1 meg is 2 counts out. 10 meg is a little bit noisy, as it tends to be, because that's what these higher resistances are like. 3 counts out. And 100 meg over range. I think the top it could do was 40 mega ohms, so that's fine. Now let's do current. So let's do the milliamp range, DC first. I'm going to start at 100 microamps. You can see I've got 0 going through and it says 0. 100 microamps, it will kind of do it. It's a couple of counts down. 1 milliamp, yep, 1 count down. 10 milliamps, a couple of counts down. 100 milliamps is 1 count down. I think this can only do 400 milliamps. Yes, it can. So 300 milliamps is 1 count down. 400 milliamps, which is the maximum. That's perfect. Just change to the amps jack. Right, so now let's do the amps jack. So I've got it set to 1 milliamp already. And I'll sort of flicker 1 up just then, but it's basically saying 0. 10 milliamps is 1 count down. 100 milliamps, 1 count down, 1 amp is 4 counts down, and the most I can do is 1.9 amps. And that's 7 counts down. But something I do like is that actually it defaults to the DC current ranges, right? So milliamps and amps, they both default to the DC. I prefer that because a lot of times you don't need to measure the AC side of it. It's usually DC stuff you're doing. And I don't actually like the way a lot of multimeters will default to AC and then you have to switch to DC. So that's quite a common thing. So let's do AC current now. So let's do 100 microamps range. I've got it set to 0 and it is doing 0. Let's do 100 microamps. 100 microamps is 3 counts down. 1 milliamps, 4 counts down. 10 milliamps is good. Oh, it's fluctuating a little bit there. Jumping around slightly. But okay, it's there. So 100 milliamps, that's fine. Bang on. Didn't like changing ranges. I just made a mistake. I hit the 1 amp range instead of dropping the value down first, and so I just popped the 400 milliamp fuse. Yeah, it happens. I have to replace the fuse now when I do the teardown. That's fine. Right, so I'm on a 10 amp range now. So I'll blow this one up, and I've got 1 milliamp on there. Nothing showing up. 10 milliamps, 4 counts down. 100 milliamps, 1 amp, 3 counts down. 1.9 amps is 1 count down, so it's just slightly better. Right, let's do a teardown on this thing and replace that fuse which I just popped. Don't forget to click like and subscribe and click the bell icon. Right, that's like messing up. Okay, plastic screws. There's no metal inserts on these. It has surface mount fuses. Surface mount fuses. Well, that's inconvenient. And that's what the insides looks like. HC32L136 GC7221AQ-LP3. Okay. ET201B board. And they're the fuses, which, yeah. It's got a bit of protection down here. PTC them off, so it's got something. And surface mount fuses. Isolation slots. So common over here. It's got them off there. Across this pin. So there's a fuse to that one, there's a fuse to there, fuse to there. Where's the current shunt? Maybe it's on the back. So this like's got 5 screws to hold the board in. I've taken out 4 already. There's one more up the top here. It's got like little clips in there as well, which I've kind of unclipped. There we go, there's the last one. So it's the metal bar. Soldering is a bit interesting. Bit of a blob there. The others look kind of okay, I suppose. Barely passable. Probably just touching up actually, I might do that. I might touch those up before I put it back together. See, this one here's not really got enough solder on it either. That one's got way too much. I might just clean those up a bit. No e-nig or anything like that, it's just hassle, looks like. And there's the switch contacts. Interesting. Looks like this maybe multi-function case and I use it for doing things and I take away the bits I don't want. Looks that way. I mean, the mould quality doesn't look horrendous, but I've seen better. So, I don't have a surface mount fuse to replace the one which is blown, which is annoying. I'm going to have to get some surface mount fuses. Just touching up some of the soldering. There's that big blob in here which I want to get rid of. Just trying to do it so the connector doesn't fall out because that'd be kind of annoying. There we go. It's definitely better. But yeah, I'm definitely not liking these fuses because even where they're placed, they're really hard to get to. I mean, you can actually get these fuses with sockets. You can actually get socketed fuses like this. So you can get a surface mount socket and you actually just plug the fuse in and out. I've seen those. These same fuses. But these are soldered on. And are you going to get in there to get that out? It's not really made to be fixed, is it? Alright, so let's see which fuse is actually blue. So this is the 10 amp, which should be fine. Yeah. We've got a fuse this end. Yep, that one's alright. And then we've got this one here. This one's blown. So the middle fuse is what's blown. Which isn't surprising because that's on the milliamps jack. So, but there's a fuse here too, which is surprising. I guess that's for the MOV, is it? I don't know. Anyway, that one there's blown. So at least it's slightly easy to get to. Damn it. So I thought I'd have a look at this actually, see if I can get easy to access to these fuses. It looks like this battery holder, you have to unsolder it to get access. There we go. So that's just 2 tabs. You have to desolder. Here we go, now it gets a lot better. But yeah, that's the way to do that, I think. But still, that's not a great design, I don't like that. I've ordered some new fuses and fuse holders, so when I do take this fuse out, I will actually take it out and install a holder. And whilst I'm at it, I'll probably do this one as well. And maybe that one, I don't know, that's a bit harder to get to. But might not be able to get a holder in there because of the spacing. It's a bit tight in there, not a lot of room. So that might not be possible, but these ones at least should be doable. So I can probably get a holder in there and then I can at least make those replaceable. These are 1808 fuses in case you don't know what they are. So to summarise the review, the meter works okay, it's relatively accurate, it certainly exceeds its specs in most cases. Very fast continuity measurement, don't like the fuses. Case is okay, it's not wonderful but it's alright. There's no rubber bumper for it, it's just solid plastic. It doesn't even say inside what it's made from, but it should be ABS. Hold on. It's not really ringing. ABS has like a ring to it. No, don't think it is ABS. Not sure what it is, maybe it's a styrene. Anyway, for the price, it's a good meter. We didn't look at much at the waveform display. I mean, we showed a little bit on the DC. We didn't really look at the AC, did we? We should do that. Oh, I've taken the battery holder out now. Yeah, but you got to see the waveform thing on the DC section to see how that performed. So, yeah, it does waveforms and a little bit of graphing to see what's going on. I think it's more of a gimmick than anything else. I don't think it's wonderful. Yeah, I don't know. It's an okay meter. I mean, I think you'd use it generally as a multimeter, not so much a graphing. I mean, the graphing thing may come in handy from time to time. You're trying to watch for something changing while you're not looking, maybe, and see what's going on. That could be handy for that, I suppose. Bad connections, that kind of thing. You could be checking for that. Don't forget to click like if you like the video, if you like what I've done, the commentary I've done. And like I said before, if you're not subscribed, make sure you click subscribe. And I'm going to tidy up and wait for these fuses to arrive before I can put this thing back together. Catch you later. Bye.